This is Ad Emmen reporting live for Prima Magazine from the ISC conference in Frankfurt. And we're here with Thomas Lippert. Recently it has been announced that he's now chair of PRAISE. But apart from that, he's also director of the Jülich Computing Center, Supercomputing Center. So welcome. Yeah. So let's first talk about the center. I heard you had a new system recently. Can you tell a little bit about that?
Yes, we have installed the first module of our next machine that we procure in the framework of the Gauss Center for Supercomputing in Germany. So this machine is called Joules. It's a machine of about 10 petaflops CPU performance and 2 petaflops of GPU performance. And when I say it's the first module, it means that this whole thing we finally want to get together is a modular supercomputer.
Okay, and when you mean a modular supercomputer, you mean that you will have different kinds of hardware in it? Is that what you mean with modular?
What I mean with modular is that we have entities which are supercomputers by themselves called modules. So let's say a system composed of CPUs mainly, and another system that is concentrating on the use of GPUs. Yeah? But they are not just brought together through a standard, let's say, connection or through, let's say, storage technology, but they are brought together directly on a joint network, maybe with a network bridge between two different network technologies or on the same network type. Yeah? And this connection between both is substantial. So it's possible that a code, let's say, that consists of a workflow can be run primarily on the cluster part and then maybe on the second part, the second module to come, which will be highly scalable. But you can also think of codes that have different parts that have different scalability properties, so that the code can be divided according to these different scalability properties into, let's say, parts that run on the cluster and parts that run on what we call booster, the other module. So this is a way where we can simplify the technology of the scaling module and concentrate a lot of technology on the cluster module. And so we will be able to do the high scalable stuff more cheap than we could do it if we have a full scale cluster system.
So the system is now up and running, or the new part?
So the first part is up and running, and the second part will come next year. But we already have a system in the top 500
yes, of course, yeah.
That is a cluster booster system. Yeah. It's called Choreka. Yeah?
It's very good that you mentioned the top 500 because Eric Strohmeyer, also in his presentation, showed a comparison of HPC centers. And on number 8 was your center. So he compared 11 centers and over the years. So it shows that, and the only European one which was consistently in was your center.
I'm happy to see that, yeah. But in some sense it's by chance, because our way to do computing never tried to be number, let's say, 1 or very, very far up in the top 500 list. Why are we in consistently over the years? Because we have 2 or 3 machines in the top 500 list. Yep. Because we try to concentrate our compute or our budget on optimizing this for our portfolio. Yep. That's the reason the Jülich Center might be appearing in this list of 11 centers.
He wanted to show that centers is more than just 1 machine or 2 machines.
Yeah, exactly.
And over the years that you consistently support applications.
And of course, with this experience, where we usually had a system which was more or less a cluster system, and another one that was more or less something like a scalable system, the blue gene, we found out, let's combine both technologies into one computer. Yeah. Because this is what we need in the future, where we have more heterogeneous type of computing, more workflow type of computing, and let's say different concurrencies in one highly scalable code. Yeah? So these different concurrencies might fit better to different technologies.
Can we now switch to PRAISE? So you are now the chairman. What do you see are the main topics for PRAISE in the, let's say, near future?
Yes, let's look a little bit back to Brace.
Okay.
Brace has developed very much into a high quality provider, high quality in the sense of the science provider of supercomputing. So it's qualified as the provision, let's say, entity for supercomputing cycles. And I think, given the future developments of supercomputing, let's say with Euro HPC, we must see how we can utilize those virtues of Brace, which is not only the cycles, but which is also, let's say, training people, going into code improvement, doing support in the so-called HLSTs, that we can, let's say, utilize all these virtues also further for the upcoming exascale, pre-exascale and exascale technologies to be provided by Euro HPC. So this would be, let's say, a maximizing the optimal, let's say, engagement of all parties, of the users, of the provisioners through Brace, and of course of the funders of technology and of the builders of technology. I want to bring, let's say, Brace together with Euro HPC so that both activities will in a maximal way profit and benefit for the benefit of science and of the users and of industry.
Okay. Thank you very much for this interview.
Thank you very much. It was a pleasure.